Only with domestic policy in the diverse areas of budgets and taxes, healthcare, education, finance, insurance and real estate, technology and communications, legal affairs, and of course, the environment. Though work on environment is but a part of Heartland's mission, although we have established a global reputation on this issue, The Economist magazine last year identified Heartland as, quote, the world's most prominent think tank promoting skepticism about man-made climate change. We're proud of that description, earned by years of hard and sometimes lonely work on many projects with hundreds of scientists from across the globe and through hosting 8 international conferences on climate change since 2008. Our work with NIPCC on Climate Change Reconsidered II, physical science, is just the latest manifestation of that work, and we're proud to stand with them today to help represent their findings and research. Speaking today will be Joseph Bast, president of the Heartland Institute, followed by 3 respected and accomplished climate scientists. First, Dr. Craig Idso. He's the founder and chairman of the Center for the Study of Carbon Dioxide and Global Change. Then it will be Dr. S. Fred Singer, who is an atmospheric and space physicist, professor emeritus of environmental science at the University of Virginia, and founder of the Science and Environmental Policy Project, or Sept. And also Dr. Willie Soon. He's an astrophysicist and geoscientist who is one of the leading researchers in the world on how solar energy and activity affects the climate. Fuller details about all 3 men's impressive professional biographies can be found in the materials we have for you in the back of the room. All 4 men will speak in that order, and then I'll open it up to questions. Now I'd like to bring up to the podium Joseph Bast.
Thank you, Jim. Good morning. The 3 scientists that we have with us today are 3 of 47 scientists who participated in writing the new edition of Climate Change Reconsidered. There's a copy of the book, 3 copies of it, on the table in the back. The book is going to the printer probably at the end of this week, and it will become live on our website at climatechangereconsidered.org at noon today. Copies of the policymakers summary, or the summary for policymakers, is also available on the table at the back. We have some extra copies up here in front. I hope you'll take a look at those. And if you have any questions, this is a good time to ask them. Global warming is a really interesting issue. Heartland has been addressing it for the past 10 years. It's a scientific issue, but it's very different from most scientific questions. Often in science, skepticism is a badge of honor for a scientist, whereas in the global warming debate, skepticism is actually used as a term of denigration for scientists. 10, 15 years ago, if you said that you were appealing to consensus or a survey of scientists, I think most scientists would respond very negatively and say that's actually the antithesis of the scientific method. You shouldn't be appealing to consensus. You should be willing to embrace skepticism. And yet in the global warming debate, it's just the opposite. Very prominent journals such as Science and Nature are criticizing scientists for being too skeptical of the global warming hypothesis. Global warming is also a social movement. If you believe that capitalism is unfair or destroying the planet or causing poverty and suffering among people, chances are you're going to believe in global warming because global warming fits that narrative. Global warming is probably happening because you're willing to believe that capitalism is incompatible with protecting the environment. And you can see that because every environmental group in the country endorsed global warming as a crisis that we needed to do something about long before the science had ever come to any definitive conclusion. Back in the late 1980s, environmental groups were campaigning on global warming. There was barely a handful of scientists who would have thought that the science was sufficiently advanced at that time to take a position on it. And finally, global warming is an economic issue. Industry got involved first because their PR departments told them that this was an opportunity to paint themselves green. Focus groups and surveys showed that consumers wanted corporations to be environmentally responsible. They were willing to buy green products, although they're not willing to spend more on them, but they say that they're willing to buy green products. So corporations said, fine, if you're concerned about global warming, we will run ads saying that we're concerned about global warming. They will run ads saying that we're reducing carbon footprint, we're recycling, and that we care, and that we're contributing to charities that do something about global warming. So the movement got a lot of funding and a lot of momentum as industry came on board, trying to paint themselves as being environmentally compassionate. The fossil fuel industry got involved as well. Now we know that the natural gas companies funded environmental groups like the Sierra Club to attack coal companies in order to get legislation passed that would handicap coal as a maker of electricity. Nuclear industry here in Chicago, full-page ads from our local nuclear power company saying that nuclear power is emission-free and therefore better than any fossil fuel. So industry on the fossil fuel side saw this as an opportunity to advance their special interests. And of course the wind and the solar and the electric car companies saw this as an opportunity to line up at the public trough and get enormous subsidies, tens to hundreds of billions of dollars in subsidies from ratepayers and from taxpayers. So what began, I think, as a poorly understood idea some 20 years ago got fanned into a widespread popular delusion as a result of all these interest groups advancing their own special agendas. Now, over the last 10, 15 years, the Heartland Institute has had the privilege, I personally have had the privilege of working with a group of scientists who have stood up against this campaign and spoke truth to power. This is a group of very courageous scientists. Many of them have had their careers damaged, maybe beyond recovery, by taking an unpopular position. Many of them have had death threats. Many of them have been ostracized on their community, in their campuses, in their communities, and yet they're willing to continue to say what they believe is true about the real science of climate change. So I think these guys are real heroes in the current public policy debate. These are genuine scientists who have something really important to say. And I will end just by saying, if you can make the effort to understand global warming, not just believe in global warming, if you just take the time to listen to real scientists and read what they have to say, you're going to discover a lot of science that you don't read about in your daily newspapers or see on television. So with that, let me hand it over to Craig Idso, the founder and chairman of the Center for the Study of Carbon Dioxide and Global Change. Craig?
Thank you, Joe. Good morning. I would like to thank each of you for being here today at this historic release and unveiling of Climate Change Reconsidered II, Physical Science. This newest report of the Nongovernmental International Panel on Climate Change, or NIPCC, presents a detailed and objective overview of science pertaining to global warming and climate change. As its name suggests, NIPCC is an international panel of scientists and scholars who have come together to understand the causes and consequences of climate change. The NIPCC has no formal attachment to or sponsorship from any government or governmental agency. As such, it is wholly independent of political pressures and influences, and is therefore not predisposed to produce politically motivated conclusions or policy recommendations. The NIPCC traces its beginnings to an informal meeting held in Milan, Italy, in 2003, organized by Dr. Fred Singer and the Science and Environmental Policy Project. The purpose of that meeting was to produce an independent assessment of the available scientific evidence on the subject of CO2-induced global warming in anticipation of the release of the IPCC's fourth assessment report. Additional meetings and publications followed, and in 2009, the Heartland Institute published the first NIPCC report, Climate Change Reconsidered, which work represented the first comprehensive and alternative assessment to that of the IPCC's prior works. Following that release, a website was created in early 2010 to further the NIPCC's efforts. There, with the help of additional scientists, the NIPCC has posted weekly reviews highlighting the findings of new papers from the peer-reviewed scientific literature that question the IPCC narrative of CO2-induced climate change. The number of reviews began to swell quickly, and it soon became apparent that a follow-up to the 2009 report was necessary. The initial outgrowth of that effort was a 2011 interim report, which work presented an analysis of an entirely new set of papers than those examined in the 2009 report. Like its predecessor, the interim report demonstrated that there continues to exist a large and growing body of research critical of the alleged consensus belief in catastrophic anthropogenic-induced global warming that is promulgated by the IPCC. In the months and years that have followed, NIPCC scientists have continued to post reviews of new scientific papers on its website that challenge the IPCC narrative, anticipating that many of those papers, with their contrary findings, would likely be ignored or downplayed by the IPCC in their forthcoming fifth assessment report. And that, of course, brings us to why we are here today. Over the past several months, our team of scientists have been hard at work preparing the latest NIPCC release, Climate Change Reconsidered II, Physical Science. As with our two prior reports, this volume provides the scientific balance that is missing from the assessments of the IPCC, which the NIPCC concludes are highly selective in their review of climate science and controversial with regard to their projections of future climate change. Although the IPCC claims to be unbiased and to have based its assessment on the best available science, we have found this not to be the case. In many instances, conclusions have been seriously exaggerated, relevant facts have been distorted, and key scientific studies have been omitted or ignored. A careful reading of our newest report, for example, reveals thousands of peer-reviewed scientific journal articles that do not support and indeed often contradict the IPCC's perspective on climate change. This fact is most unfortunate because in compiling their studies, the IPCC was either purposely blind to views that ran counter to the materials they utilized, or its authors did not invest the amount of time, energy, and resources needed to fully investigate an issue that has profound significance for society. Either way, the IPCC is misleading the scientific community, policymakers, and the general public by telling only half the story about the science of climate change. If the IPCC truly considered and acknowledged all pertinent science in its assessment reports, there would be no need to have a NIPCC. Until such time, however, the NIPCC will continue to inject some balance into the scientific debate by finding and reporting the scientific research that the IPCC overlooks. Much of our current report deals with natural climate processes or variability, weaknesses in climate models and data sets used to measure temperatures or forecast future climate conditions, or with data that raise serious questions about the IPCC's attribution of climate change to human greenhouse gas emissions. Our sole goal in presenting this information is to enable fellow scientists, elected officials, educators, and the general public to make up their own minds about what the science says, to understand climate change rather than simply to believe in it. Each of the 7 chapters in this volume begins with a list of key findings that contradict those of the IPCC. These findings are then discussed in detail using in-depth reviews and analyses of literally thousands of scientific papers. Full citations to the work reviewed are presented at the end of each section. NIPCC scientists have worked hard to remain true to the facts represented in the studies cited in our report. To that end, we often use direct quotes from the original authors in describing the importance and implications of their work, demonstrating that the interpretations and conclusions presented in our report are faithful to the views shared by numerous other scientists across the world. With that introductory background and history of the NIPCC, we will now share with you some of the key findings presented in the 7 chapters of our report. Fred Singer will discuss material from chapters 1, 5, and 6, covering climate models, the cryosphere, and the hydrosphere and oceans. He will then be followed by Willie Soon, who will discuss the findings of chapters 2 and 3, which cover various climate forcings and feedbacks, including those related to the sun. Finally, I will return to conclude with some thoughts about global temperature and extreme weather, which are the topics discussed in chapters 4 and 7. After that, we will open for questions. Fred?
Thank you, Craig. I'm supposed to cover the ocean and everything else in 8 minutes. Well, ocean covers 71% of the Earth's surface and is a very complicated place and not too well understood by anyone. The cryosphere, that's all the ice on the Earth, is mostly in the polar regions, on Greenland and in the Antarctic, and on glaciers, and interacts with the ocean by releasing water to the ocean. Or when the ocean gets very cold and evaporates water, it freezes and becomes ice. The place where all this comes together is in the subject of sea level rise. And I've been concentrating on that one particular area, the rate of rise of sea level. That is a very important subject, particularly for people who live in Florida and on the coast. It doesn't affect people so much in Chicago, although, well, yeah, maybe it does. Depends. We found that the IPCC has not done a very good job on sea level rise. In their 4 reports so far, they've changed their mind 4 times about the rate of rise. And in the forthcoming report, and I've just gotten a sneak view of it, they are now plugging for higher rates of sea level rise. They're really all confused. It was this problem with the IPCC that led us to set up NIPCC about 10 years ago. We found that the IPCC was highly selective in the kinds of scientific information they included in their reports. They wanted to boost the idea that the human role is the most important in changing the climate, and they ignored particularly the effects of the sun. I think Willie Soon remembers that. He was present with us 10 years ago in Milan. It turns out that the sun is, in fact, the most important factor in all of climate change. Not surprising, but it is not included in the climate models. The IPCC simply ignores the published evidence. Published, I might add, in peer-reviewed, respectable papers by people who are not necessarily meteorologists, but could be astrophysicists who understand more about the sun than people who work on the weather on the Earth. Anyway, I will leave you with one little thought. I've been with us now since the beginning of the IPCC in 1988. So I know a lot about the history. And I remember that in their 3rd report, published in 2001, they finally came up with some numbers. They said they were 66% sure that the cause of global warming was human, and specifically the emission of carbon dioxide. A few years later, in 2007, in their 4th report, they upped this number from 66% to 90%. I don't know why. But they suddenly decided now they're 90% sure. In the forthcoming report that will be released next week, they now say that they're at least 95% sure. It's a joke. The funny thing is that all during this time, the climate has not warmed. So what are they sure about? They're sure that the human cause of not warming is there, or are they? I leave you with this thought, because we consider the IPCC to have failed in their mission. And we consider that the NIPCC is necessary to come up with a report that takes care of these neglected areas and tries to balance the record. Thank you very much. Willie, you're next.
Support. All right. Good morning, everyone, and thank you all for coming. I guess I'll just start straight into what Fred has just introduced the subject really well in terms of all the effort of all these independent scientists who really try hard to assess what are the truth in terms of the understanding of how the climate system really operates. And our conclusion is fairly clear for now, because we really couldn't find the effect of this greenhouse effects of CO2 impact on the global system. We cannot find it in a measurement of temperature. We cannot find it in the ocean temperature. We cannot find it in the stratosphere. We cannot find it in the troposphere. We cannot find it anywhere you choose to find. Okay? And then, because that the predominance of using climate models, that I want to make a strong comment on this. The state of our current understanding is simply not mature enough to model so many things, and I'll give you one specific example in a minute, so that we will be able to sort of saying, oh, we use the climate model, we can actually project, what the temperature will be 100 years from now, given what the CO2 trajectory is going to be, which is always keep increasing. Here's a simple example. If you ask yourself, can the climate model even simulate or calculate what the trend of the seasonal cycles of the Earth temperature? We know that we can measure these things. Can they measure that well at all? If you look at the report from the AR4, which is the 2007 report, you find that none of the model predicted correctly how basically the amplitude, which is the amplitude of the seasonal cycle, how large or how small it is, 10 or 30 degree. And actually the timing of the season itself, they all got it wrong, every single one of them. So with that aside, let me not start telling you that how IPCC has somewhat strangely ignored what the sun can do to the climate system. To explain that, I want to provide a very simple analogy, which hopefully that you will understand, but is very, very accurate. To me, it's very important to provide the correct and accurate representation of what the story is. For CO2, imagine that CO2 is Willie Soon. He's very greedy. He probably take a lot of money from Greenpeace, and then he ate too much hamburger. And then for the sun, it's actually the King Kong. I call it the King Kong of the climate system. What IPCC is arguing is, because Willie Soon is so greedy, CO2, he's been eating a lot of hamburgers, so he gained a lot of weight, so I'm getting fat, right? And then the sun is on diet, he's taking some water, so he's gaining a little bit of weight. And then they suggest that because Willie Soon has gained so much weight, guess what? I'm supposed to be able to push the climate system, now represented by Refrigerator Perry, which I hope some of you know, he's Chicago Bear, right? Big guy, right? I mean, I'm supposed to be able to push that because I ate a lot of hamburger? That's basically the idea. Quantitatively, you will look at it. This is how they have twisted the topic and make it very not understandable for normal people, which actually, I'm just a normal scientist, normal people. I just want to find out what the truth is. Finally, I want to address the issue of so-called forcing and feedback. The way it's set up is very clever, by the way. They will always give you something that seems very inevitable if you just follow it to the logical conclusion. The idea, one of the best idea about how the IPCC misrepresented this forcing and feedback issue is that almost all their forcing will produce only enhanced or positive feedback, so-called, which means if you give an ounce to this, you will gain 3 ounces out of this because there's a positive feedback in the system, rather than what the reality is saying. What we know from climate system is that sometimes when we put in 1 ounce, we actually get less out of it, okay? Because the system has negative feedback. The direct example is that if you were to add CO2 to the system, ask yourself, would the cloud cover increase, decrease, or stay the same? By the way, if you really want to know what the IPCC model produced, I can bet even the 5th assessment, we're not supposed to comment on that, they will produce the answer that one will say it's increased, one will say it's decreased, one will say it stayed the same. In science, if such a proposition is allowed, that you give one effects that you produce just about every answer possible, and you still want to maintain that you are being neutral, that is silly. Okay? And the problem is that in climate system, we at least have a lot of very serious study on what the cloud can do. They were proposed to use that if you add CO2, you will start melting the ice, so you decrease the planetary albedo, so they will absorb even more solar radiation. But excuse me, what if for example, ice will be in the Arctic region? What if the Arctic cloud started to produce more Arctic clouds, so reflect more sunlight, therefore cool the system? We have found it over and over again, over many geological epoch and climatological era, that these are all very common phenomena. The system swing up and down in a very natural way, because the system is always, every time the positive feedback go up, the negative feedback will pull it down. I think I better probably stop now, because probably it'll give you a bit of a headache, but please ask questions, and then please do try to read the report that we work very hard on. And I really want to commend Craig Idso and Fred Singer, and of course a colleague of mine, Professor Bob Carter from formerly from James Cook University. He's not here today, but then all of them work very hard, and then many of our co-authors work very, very hard, and then especially the reviewer that is actually volunteer their time and then really do very well in terms of setting us straight on what we say that is wrong, that is, very challengeable and things like that, and provide a lot of references, for example. So with that, I'll stop now. Thank you.
Thank you, Willie. So to conclude, I will talk a little bit about the temperature and the extreme weather chapters and some of the key findings there. But just to preface that really briefly, our volume is really is organized in such a way that we start with the climate models. We start with that because that is where most of these projections of the IPCC stem from. And then the next thing that we do, chapter 2, we then go into the forcings and feedbacks, where we provide and show that there's many other factors out there that exist in the climate that can explain a lot of the current trends that we're seeing. And then in chapters 4, 5, 6, and 7, we deal strictly with observations. We deal with real-world data, and we test those data against the model projections of the IPCC. Is the climate system and various aspects of it, is it behaving in a way that the climate models are projecting? If not, why? Why not? And so in chapter 4, we deal with temperature, and here, one of the greatest projections of the IPCC is that, of course, temperatures are going to be rising. In fact, they already are rising in response to the supposedly unprecedented increase in CO2 that we've had over the past, since the Industrial Revolution began. And we look at that. We look at temperatures. We see, are they behaving in a manner that the models suggest they should be doing? And we find that whereas the IPCC suggests that temperatures of the past millennium are unprecedented, unnatural in nature, we find that actually it's just the opposite. There's nothing unprecedented, unnatural about the behavior of current temperatures, and we explain why. We go through the cycles of temperature that have been existing for forever, for that matter, for many hundreds and thousands of years. So we conclude that the modern rise in CO2 and other atmospheric greenhouse gases have had little, if any, measurable effect on 20th century climate. We also explore the impact and influence of urbanization and land use change. The IPCC claims that they have filtered out these influences and that they don't bear any imprint on the current temperature record. Well, we analyzed several papers that demonstrate that they do, and they could account to as much as half of the warming that we've seen over the past century or more. Another thing we discuss in the temperature chapter is one of the signal claims of global warming, of CO2-induced global warming, is that the polar regions of the planet should be experiencing this incredible warmth and showing the first signs of this. Well, we show that claim of robust evidence, as the IPCC puts it, is patently false. We demonstrate that temperatures oscillate in the Arctic independent of CO2, and they have done so for millennia and more. We also, of course, one of the main parts of our chapter is we examine temperature record of the past 1,000 years, where we in particular look at the medieval warm period. Here, the IPCC has long claimed that the medieval warm period is not a global phenomenon. It's pretty much restricted to the North Atlantic and the countries around it. And we demonstrate that it indeed was a global phenomenon, highlighting papers all across the globe from every continent, showing that indeed the medieval warm period that existed about 1,000 years ago temperatures were as warm, if not warmer than they are today, when CO2 concentrations were much less, and that there is a natural climate oscillation that occurs on this millennial timescale that can full well explain the current temperature increase of the modern warm period. Shifting over to the extreme weather chapter, a couple of claims here. We often hear that global warming is going to cause an increase in all sorts of extreme weather, from droughts and floods, wildfires, and so forth. And so we go through the peer-reviewed science and we say we see what is truly happening. You can start out with any location on the earth and show that, okay, this location has had an increase in floods or an increase in droughts over this particular time period, over the last 20 or 30 years. But when you expand the temporal view and the spatial view of this analysis, you find that there is no CO2 signature in this. You find that there was floods and droughts that occurred in the not too distant past that were of much severe and greater intensity and frequency than we're seeing now. So you cannot point to current events and say that that is a cause of CO2 when you can show that they occur with regularity in past climate. Same thing with stormy weather. The NIPCC finds that there's been no significant increase in either the frequency or intensity of stormy weather in the modern era. Also, despite the and again, a lot of these claims the IPCC says is coming right now, that we should be seeing the existence of some of these extreme weather events right now because of this supposedly unprecedented global warming that we've been experiencing over the last 2 to 3 decades. But yet we find, looking at hurricanes, for example, tropical cyclones, that indeed there has been no increase in the intensity or frequency of tropical cyclones globally or in any of the specific ocean basins. It is just not occurring as the models suggest they should be. So time and again, not only through the temperature and the extreme weather chapter, but the cryosphere, the hydrosphere, the oceans, and all of these observational chapters that we cover, we show, not through our own words, these are papers that we are citing of researchers who have conducted the studies, not ourselves in most instances. These are other researchers across the globe coming to these conclusions. We use their quotations to demonstrate what they are finding. And these are things that the IPCC is not including in their studies, and they should be. So, in closing our initial remarks to this press conference, we wish to thank all those who participated in writing, reviewing, editing, and proofing of this volume. Our sincere hope is that this report will mark a return to a more balanced and factually driven analysis of an issue that is in desperate need of much fuller and open discussion, and that it will help policymakers and politicians make rational decisions on climate and energy policy based on all the pertinent science, not just the one-sided narrative of the IPCC. Thank you.
Thank you, Craig. Thank you, gentlemen. We are going to open it up to questions. Just a reminder that digital version of the full report and the summary for policymakers can be found at climatechangereconsidered.org at noon today. And there's also thumb drives for anybody who would like to take the full report home with them today. And so with that, we'll open it up to questions.
I have a question.
Sir.
So I think, for the lay people out there, they get confused a lot by the debate around climate science. Let me just throw out one sort of conflicting scenario. One is that where the last 17 years, global temperature has not changed and increased, as the hockey stick would predict. Then we have the president in June saying in the last, I don't remember the exact numbers, but in the last decade, or last 12 years, there's been 5 or 6 or 7 of the hottest years on record. Can one of the gentlemen please explain how these two things can be true at the same time?
I'll try to answer this question. It refers to historic temperatures. There's no debate at all about the fact that the climate changes. No, none whatsoever. Everyone agrees. And there's no debate about the fact that the climate is both cooling and warming, not at the same time, of course. In fact, we have a book out, which you can get on Google or Amazon, called Unstoppable Global Warming. Every 1,500 years, there's cycles in the climate, and we try to explain those. As we look for published papers that explain them. Yeah, we can't explain everything, but there are many people who work on these problems. There are a few instances in recent years when the climate has cooled. For example, between 1940 and 1975. And some of you I still remember it. Some of you may or may not. There was great concern about a coming ice age. Books were being published called The Coming Ice Age. Time magazine and Newsweek had front page stories about a coming ice age. People were imploring the government to do something about it. Like, what could the government do about a coming ice age?
There's actually a National Science Report, National Academy report also.
Do you remember that? Yeah. In around 1970, in the early 70s, this was the big problem. Now you asked about whether there has been a stasis or hiatus. That was fairly rare. The only one that I'm aware of is the one in the last decade or 15 years, when there has been, in fact, no temperature increase, no general decrease. There are fluctuations from year to year, but the trend has been essentially flat, zero trend. Whether this will continue or not, I don't know. It seems to be not caused by human activities, that's quite clear. Carbon dioxide has been increasing rapidly, more rapidly than heretofore because of efforts of China, particularly in building coal plants. Craig Idso will tell you that's very good for agriculture. We need more carbon dioxide in the atmosphere. It's a benefit. But in any case, it doesn't seem to have affected the climate. This has caused a serious problem for those who believe in the IPCC. And we're anxious to see how they will deal with it when they finally publish their summary for policymakers next week.
Great.
Will they finesse it, ignore it, or will they try to explain it? It certainly disagrees with the climate models. Gets me back to the models. The models did not predict this. And models, to my way of thinking, are very nice, as long as you don't believe in them. They're very nice. They allow you to test various ideas, what if you change this, or if you change that. But please remember that none of these climate models has ever been validated against actual observations. That's different from weather models. Weather models are validated. Working meteorologists who work with models validate them against actual observations. And they more or less, they do work. Or they work fairly well. And they're improving. Climate models have never been validated. So they're very nice, just don't believe in them.
Willie, did you have something that you wanted to
I
add?
thought I'll just quickly add is that to reconcile that, there's nothing to reconcile really. You are actually at an upswing, right? And then you have this flat trend. Plus that, remember, those statistics of 5 of the 12 warmest year and all that. Please think about it this way. The average global temperature, absolute, it's of the order of 14 to 15 degrees Celsius. Okay? This number that we're talking about, all fluctuating between 0.1, 0.2, no more than that, or 0.005 or 0.05 like that. So it's ridiculous for them to play this game that this is some statistical thing, because you're at the upswing, of course you're going to have some of the high, but then it doesn't mean anything. What I'm trying to tell you is that this statistic is completely bogus, cannot be demonstrated. And that's why they play these word games. In my opinion, humble opinion, that this is all wrong stuff. We can really bring serious statisticians in to try to discuss this issue, because it's just very sad that even US president can misspoke about this or misinform about this.
I need to add one more thing to this, to answer this question. It's a profound question and deserves a considered answer. What does the IPCC and other global warmers have to say about the fact that the temperature is not increasing? They finesse it. Here's how they finesse it. It's a trick. I'll tell you what the trick is, and once I tell you that, you'll be able to recognize it. The trick is they finesse it by saying, yeah, but the 10 last years were the warmest in the recorded record. That's correct. It has nothing to do with trend. You see, they're trying to confuse you between trend and level. They even measure it differently. Trends is measured in temperature in degrees per decade. Level is measured in degrees. These are two different concepts, measured in different ways. So this is just an attempt to confuse the public and the media. And to a certain extent, they succeed. Because people do not make a sufficient distinction between temperature level and temperature trend. It's temperature trend that's important, because as CO2 increases, the models tell you that the trend should match that. You should see an increase in temperature, not a level temperature, an increase in temperature, and you don't see it.
Very good, thank you.
Have you presented any of these findings to a peer-reviewed conference, people who know as much about the subject as you do?
The question is, have we submitted the report to a peer-reviewed council?
I can only speak
Can
on
you come up
behalf
here,
of
Will?
my own work. Anything that I have to do in any subject, especially on the issues of sun and the climate, I obviously publish them and go to present in major conferences, as anybody is. Yes, that's for sure. And then sometime, I guess you couldn't get much discussion out of it, but just sort of, well, I don't have any hostile reaction, put it that way. They just basically study the thing and then we just move on. There's one more structural problem about the upcoming IPCC AR4 related to solar chapter that I wanted to say it. So that, because I wonder how many of you really know this or will ever find out if I don't say it. That's my duty, is to tell you the story, the truth. If you look in terms of the chapter on solar, covering solar forcing, it's actually chapter 8. Please look at the list now. I'm sure chapter 8, of the IPCC report. I'm trying to talk about the structural problem, how they were political organization rather than a scientific one. Because how can you have a solar forcing chapter that have barely one, quote unquote, somebody that has any relevant publication, since you talk about peer review, any mildly have any relevant publication record on solar physics? That named person is Blanca Mendoza from Mexico, okay? If I may go further, I even know how she got appointed to be an author on this IPCC list. She was appointed, so it's so-called nepotism. It's appointed by her husband. So this is what the structural kind of problem that many people who don't study the issue don't understand. You may say there's nothing wrong with that, but then I find it very wrong when you make so many strong statements that the sun could not do this, could not do that, but then you have nobody qualify, and then you ignore many of the papers that we have published, or many other people have published, and not cited in the report. So that's called, I don't know what you call it in scientific sense, but then you just basically ignore the evidence, which is really not the proper or good way of conducting science.
I would like to answer your question as well about the peer review. In many ways, I consider this volume to be doubly peer reviewed, and here is why. Number one, we're not presenting original work. We have summarized the work of others that has been peer reviewed. So every paper that we've gone through here, we're pulling out quotes and the key findings of those papers. But the authors themselves have said, and that have gone through peer review already once. But that said, we wanted to be a little bit extra careful, and this time we did subject this volume, each of the chapters, out for peer review according to normal journalistic standards. So each chapter was peer reviewed. It was sent out to a number of different scientists. They sent their comments back in to the editors. We in turn sent the comments back to the authors and asked them to deal with them appropriately. And we went through that process. So in a way, it's been peer reviewed twice.
Basically,
That's a very good
you're
point.
presenting your ideas to a couple of general assignment reporters who have, I don't know about my colleague over here, but I've got a bachelor's degree and that's it. There's no way either of us could critically analyze or present contradictory, I guess I can't speak for this gentleman here. There's no way I could present.
No PhD, I'm sorry.
Any contradictory evidence. I mean, this is like shooting ducks in a barrel. It seems like the fact that you would even present it to a lay audience would indicate that you don't think you can hold your own against regular scientific view.
Well, normally you have the publication come out first, and then you go around and you then make the presentations. Now, this past June, we actually had a couple of meetings in China, where we spoke at 2 meetings that were put on by the Chinese Academy of Sciences. We were invited to come and give a presentation on the NIPCC findings as well there, and that's all documented on the website as well. Our meetings there. We do anticipate that various of the chapter authors and reviewers and contributors will. We expect them to go out and make presentations at the various scientific venues that exist out there. So this is, I would consider this the beginning of it, not not the middle of it, and certainly not the end.
Dr. Janet Francis at Rutgers University, who's a climatologist, just did an interview saying, as if it were given, that the difference between the temperature of the Arctic areas, where the Arctic ice areas, and lower latitudes has been decreasing. That the ice in the Arctic is basically, those areas are getting warmer, lower latitudes are staying stable, the difference is diminishing, and that this is having some significant effect on weather patterns. I don't know if you know about her work, but I mean,
Yes,
is
Jennifer
this
Francis.
true?
Yeah, we know her. It's not Janet.
Jennifer.
Jennifer.
Jennifer Francis, yeah.
We know her work.
Did you want to comment on that?
Rutgers.
Well, tell them to read the cryosphere chapter. Because these are all also statements that she make it off her cuff, and then I don't know what she speaks specifically, but yeah, there are a lot of people who publish paper on those issues of how changes in the Arctic sea ice could affect the weather patterns, the jet stream, right?
Yeah.
But then the most significant puzzle about the sea ice issue, which is very obvious, of course, you have the Arctic sea ice decreasing, but only peaking the September month. But then you have the Antarctic sea ice actually increasing somewhat. And then when you take the global average, the sea ice actually look remarkably stable, up and down, global. So if you want to propose that the CO2 can cause the Arctic sea ice to decrease, and then you have to really account for the Antarctic sea ice to increase, that is another very important missing step. I mean, so far none of them has ever addressed that issue very directly or explained to some of us, because these are scientific matters that ought to be discussed, no doubt about it. But then to try to turn it around and say that it's CO2 and has to be CO2, I think we got to take a step back, right? Because we simply have not understand the system well enough to confirm that this is a CO2 effect, because it's just
And proof of that,
it could very well be just part of the
exact.
system.
And proof of that is you can look at temperatures in the 1920s and 30s in Greenland and other areas of the Arctic. We find that they were just as warm now as they were back then. And CO2 was much less in the atmosphere back then, and certainly didn't cause the warmth back then. And you can go back further. We document in the volume on temperature, we have a whole section on Arctic climate. You can document how you go back further and further in time and find that there's natural oscillations that can fully well explain this. So just saying that the temperatures have increased in the Arctic doesn't mean a whole lot. You have to understand why. Why has it occurred? And if we find that it's been occurring naturally, like clockwork on these cycles, well, when CO2 concentration is much less, I don't see how you can make such statements that it's proof in the Arctic that CO2 is driving climate change. And then Willie makes another great point about the Antarctic. The Antarctic is totally misbehaving from what the model projection should be suggesting. The Arctic sea ice is expanding equatorward. Temperatures since 1950s are pretty much constant, if not declining, with the exception of the peninsula, where temperatures have increased, but for the continent as a whole, in Antarctica, temperatures have not. So,
I want to add a very significant observation for you to consider, which have to do with this very well-known Arctic warming in the starting about 1918 to about 1940s. I studied the Arctic very extensively. This is the kind of observation that is very, very interesting. You can say that instrumental measurement, thermometer, maybe not well calibrated back then. So what's the best test that one can find? There is one evidence that is really interesting in my view, which is to tell you that the relative warmth of 1930s versus, let's say, warm today. No doubt it's warm, actually, okay? You just go to a location near northwest of Greenland called Upper Narvik. Go look around the water there now. See if you can find some codfish. But in the 30s, they found codfish. Sometimes they even find sharks that are swimming up there. If you go there right now, you will not find those guys there. You will find that because the liver is too cold, they will die. So what I'm trying to give you is that at least from, even if you say that thermometer data is not good, these are some of this kind of data, this kind of information that ought to be not ignored. So for them to keep claiming that it's CO2 causing that, by the way, so please understand that 1930s, I don't think that the CO2 can explain any of the warming in the 30s, okay? If we can agree on the same benchmark. So therefore, I'm trying to tell you, the natural changes is extremely large in the Arctic system. What we have observed so far, especially from the satellite measurements, it's extremely short in our human impatience, I guess. Climate doesn't get defined by this 20, 30 years period. By the way, even back to the basic, what is a climate? Can anybody tell me? I mean, World Meteorological Organization, IPCC, please let anybody try to explain to me in the face or that makes sense. They say that climate is just the average of the 30 years weather. So, naturally, all of us should ask, why 30 years? Why not 40 years? Why not 35? Why not 50? Why not 100? It is simply because the subject is so immature. And then we have a lot of impatience in most people, I think, that they all want that instantaneous answer where the science is just simply not cope up to the knowledge. But then I can also say that there are certain facts that we do know, like the one that I gave you on this codfish in the Upper Narvik region. So that makes a perspective is very important, this historical and this paleo information or even geologic timescale. That's what I have to say about this. Thank you.
Your questions raise a lot of issues. So let me add another point to clarify, not to confuse. One of the questions you might ask me is, well, why are these temperatures of the 21st century the highest in recorded history? Recorded history means with thermometers, so that's 150 years. Why are they the highest? How come? And the answer is very simple. The answer is that the Earth experienced what we call a little ice age from around 1400 to 1800. It's part of the 1500-year cycle that I mentioned earlier. And we're coming out of that little ice age now. So there have been jumps in temperatures. And the reason these levels are the highest is because of previous temperature jumps. Previous temperature jumps. For example, there was a big jump in temperature in the early part of the 20th century, which by no means could have been caused by carbon dioxide. There simply wasn't enough being produced by humans to make any difference. There still isn't, actually. But that's another story. Gets us into another feature. Yes.
Can I ask about sea level?
Sea level, yes.
The IPCC, I've just read in the popular press that they're predicting a 3-foot sea level rise by the end of the century, I believe. And I've seen Al Gore has predicted 16 feet by the end of the century. What do you think will rise could
Okay.
be based on the, for example, ice sheet?
Let me first of all talk about the IPCC. In their 4 reports so far, they have changed their minds about sea level rise 4 times. And in the forthcoming report, they will again change their mind. Historically, we know a great deal about sea level rise. We know, for example, that during the depth of the Big Ice Age, about 18,000 years ago, sea level was 400 feet lower than what it is today. You could actually walk from England to France. Florida extended way out into the Atlantic. You can see the evidence. The evidence comes from corals, mainly. Coral reefs, which tend to grow and always stay just below the surface of the ocean. Now, the estimates for 2100, for the year 2100, vary a great deal. From 7 inches per century, which is what it has been in the past few centuries, to 20 feet. Big difference between 7 inches and 20 feet. 20 feet, by the way, is not just Al Gore, he's one of them, but James Hansen, who is a serious scientist. Al Gore has used his numbers. But where does Jim Hansen get 20 feet? Okay, I asked him. He assumes that Greenland will tilt and all the ice will slide off Greenland and go into the ocean and melt. Well, you know, that's kind of a far-reaching assumption. Where does 7 inches come from, which is my number, for the year 2100? Another 7 inches. It comes from the historic record. There's no reason to think that humans have any influence at all on sea level rise. It's like the tides. We can't change what's happening. It's inexorable. It's built in. Sea level has risen. It'll continue to rise. It'll keep on rising. It'll keep on rising until the next ice age. And then sea level will drop and ice will accumulate on the continents as it did 100,000 years ago. We know that because there have been 17 of these ice ages in the last 2 million years. And we can see the record both in temperature and in ice, and that's what the record shows. When it gets cold, the ocean level drops and ice accumulates on the continents.
Have any more questions? All right, hearing none. Thank you all for being here, and these gentlemen will be heading back to the offices